I think I should start off by making one disclosure. As you see, the topic of this is aligning the headlines with the science. And about 35 years or more ago, I had another career and I wrote a newspaper column. And the column was called Food for Thought. And I wrote it with Jean Mayer, who was my mentor and uh, the, the man who did the first White House Conference on Food, Nutrition, and Health. Does anybody remember Joyce Brothers? You remember Joyce Brothers? Okay. All right. Well, the story was that with this column, it was called Food for Thought. And one day I got a letter from one of my former interns. And the letter said, "Have you changed careers?" And the reason was because she was in Detroit, and I think it was the Detroit Free Press. The column had been published, and the headline, the person who did the headlines got mixed up. And so he put the headline on Food for Thought in our column with my face and Meyer's face. And the headline was, "The risk of impotence for both men and women is very great." And this was a column, I don't know what it was, about chickens or something like that. And ever since then, I've worried about aligning the headlines with the science, and that's my disclosure. But today, we're going to have a wonderful session. I guarantee you, I've seen some of the slides. We've got two speakers to share their initial thoughts. And after that, we'll introduce the additional members of the panel and engage in a dialogue on this topic, not on Joyce Brothers, who was the column they got mixed up on, the sex column. Our first speaker is Maria. Maria Hegstad is managing editor of Inside Tosca, and that is not an opera, and the Risk Policy Report, and they're both websites from EPA. So it's all everything you need to know about EPA, where she's covered a whole bunch of things: chemicals, risk assessment policy, toxicology, epidemiology, and so forth, since about almost 12, 15 years. Yeah. So Maria, she's going to be discussing the importance of context in crafting the science and stories. And Maria, just delighted you could come and be with us. Please come.
All right. Well, thanks so much for the invitation. It's a pleasure to be here and talk about what we do. So I am with Inside EPA. It's part of Inside Washington Publishers. It's what we call trade press. It's pretty common here in DC, and so the purpose is to write about public policy in different parts of our company, look at different parts of the what different regulatory agencies do, how regulations are made. I'm part of the environmental group. We don't have a group that works on nutrition, or Steve would have probably asked someone from there instead. But here I am, and what I focus on mostly is chemical risk assessment, what sorts of chemicals you find in different environmental media, how you look at the science about what kind of toxicity they have, how people can be exposed, conducting toxicological assessments, the dose response assessment, how much of chemical X in surface water that may become drinking water could potentially be harmful for which populations, why that might need to be regulated, and to what extent, how, things like that. So as just mentioned, there's two pubs that I write for. A risk policy report, which is the one that really focuses on how EPA conducts risk assessments, which assessments it's working on, that kind of thing, has been around for a number of years. And the focus there is really on what we see as kind of a dual translation. So As you can see, the tagline on it, it's for scientists interested in environmental policy and policymakers interested in science. And the idea is to try and look at how the science and the policy kind of drive each other, or hopefully they should, right? You want to see the policy responding to the science. And obviously when policy questions come up, science will be applied to try and address those. Inside Tosca is a newer pub. We actually just started this early in the pandemic, but it's also very focused on chemicals, particular type industrial chemicals. So it's sort of the catch-all statute that covers chemicals that aren't pharmaceutical products, aren't pesticides, things that have their own specific category. And this is actually a very old law. As environmental statutes go, the Toxic Substances Control Act was first put into place in 1976. Congress just reformed it in 2016, and it really drives a lot of new risk evaluation requirements for the agency. They now have sort of an annual quota that they are supposed to be working on, deadlines for how long it takes to do that, all that sort of thing. So we wanted to really focus on that process. That's the reason for the new pub. So that's what I do. And I thought it might be helpful to kind of walk through an example of how we try to write about science and put it in the context of the public policy. So I think what you'll see pretty quickly is the kind of science I write about is very applied. I don't do writing about things that are interesting purely because it's new and interesting science. It's all science that is applied in a public policy kind of sphere. So I was trying to think of an example I might have that would be at all nutrition related, since I mostly work on chemicals. And the one I came up with is one I found really interesting because it's not just a straight, let's talk about what's risky and how you limit your exposure to it, but it's a very interesting risk-benefit trade-off, and that is methylmercury in fish and the advisories that federal agencies craft for a particular group of people, those that could become pregnant or are pregnant, and as it has sort of evolved, young children as well. So this is actually a story arc that's been going on for more than 20 years. And I was looking back in our archives to try and start sketching this out for you. And I realized that we had some stories as far back as the mid 90s on this. In some of our older publications, you'll start seeing headlines talking about how it's a sudden explosion of local fish advisories, which is where a state or a local agency is telling people, all right, you don't want to consume this fish, or you shouldn't consume more than a certain amount because of these contaminants we're finding here. And there was really a policy appetite from that for seeing a more uniform federal advisory come out for this particular population. So that's kind of what starts kickstarting this. And then you'll see some more science headlines. EPA and NOAA start looking at what sorts of concentrations of different kinds of contaminants you find in fish. Not only methylmercury, although that's a pretty common one, but also things like PCBs, dioxins, things that are persistent. And that eventually leads to multiple agencies trying to assess methylmercury and its risks for human consumption. And what often ends up happening with these scenarios is that sort of a higher authority, as it were, comes in and is sort of asked to mediate the differences between those agencies. So you'll see this in this first headline we've got here, the National Research Council, part of the National Academies, was asked to do a study on methylmercury. And so they came out with a report which essentially established what's now sort of viewed as the risk estimate for methylmercury, looking at developmental neurotoxicity as the effect, the endpoint of concern. And so this kind of then kicks off our policy approach to addressing this. You see very shortly after this, Congress gets involved and they want to see some sort of advisory come out of the agencies. You've got senators from different parts of the country with different views on whether what we've seen so far in the science is sufficient to come up with an advisory or not. So that's sort of the debate here in this story. But this was the first that I could find national advisory to those who are or could become pregnant on methylmercury. And it was very simple. It was just don't eat these 4 kinds of fish. And as you'll see, the science sort of continues exploring this issue. And you'll find more studies that are saying, oh, hey, we're potentially seeing more risk, more people exposed to this risk. And so EPA and FDA end up coming out in 2004 with a new advisory that is trying to lower those risks by saying, okay, we're going to put a ceiling on the amount of fish that we suggest people eat. But as these things go, then of course, from the other perspective, you start seeing a nutritional concern coming up in some of these studies, and people are saying, well, wait, if you're really reducing the amount of fish that people are eating in the country, and you're reducing the benefit people get from eating fish. And the thing that I find so fascinating about this particular example is you're consuming one thing which is giving you both a risk and a benefit, and it affects the same population of people, and it's on the exact same endpoint, because you're looking at beneficial oils that are particularly important for fetus and infants' brain and eye development, and then you've got a very potent neurotoxicant, which is going to be a detriment to that exact same system. So this story continues on, and in fact, it's still going. FDA tried to address this really interesting risk-benefit scenario in 2008, 2009. They came up with a model that tried to model both the risks and the benefits of eating fish. And this led to a big interagency spat between the 2 agencies, because there were certain researchers within EPA that really felt that it was insufficiently protective from the methylmercury concern. And all these years later, you get a final advisory in 2017. And this one, again, is trying to balance the risk and the benefit that you see coming up in all of these studies, because it expands beyond, don't eat these 4 fish and don't eat more than 12 ounces a week. It suddenly has a floor. And they're saying you should eat at least, I think it was 8 ounces a week of fish. So that's kind of where we are now. Although, as I say, this story still goes on, because EPA is still trying to update its methylmercury risk estimate. The number that is the basis for this 2017 advisory is, I think it was set in 2001. So at this point, it's pretty old. There's been, of course, a lot of new research. Science marches on. And there are questions about whether the number EPA is using as the basis for this is still protective or not. And at the same time, FDA is moving on too, and they've recently in a regulatory sense, last year, kicked off a new program that is trying to look at heavy metals in foods that are frequently eaten by young children, the Closer to Zero program. And that's going to be looking at different forms of mercury as well as arsenic, lead, cadmium too, if I remember correctly. So the story is not yet written, but that's kind of the arc, and hopefully a good example of the kind of stories that we try to tell, and a good example of how the science and the policy hopefully influence each other, and how we try to show that. So I thought I would also try and talk a little bit too about the process for doing this. It's probably the main reason I'm here. And so I guess what I was trying to think about my process for doing it is, how I approach interviews with scientists. So as I was mentioning, I mean, mostly what I write about is very applied. So a lot of the questions that I ask have to do with the context. What was the impetus for your research? Frequently, that's some sort of public policy issue. An agency is trying to make a decision about a particular chemical. There's an ongoing assessment. They're trying to look at whether there's a new exposure pathway that they should be concerned about. What additional research might be needed to fill those gaps, things like that. So that's one aspect I'm always going to ask about is why is that? Because that'll often help me understand the context for it. How might a new study that you've just published, how might that inform the policy or the decision making? Questions like that. Of course, we're always going to ask about strengths and weaknesses of the method, the analysis. Pretty standard stuff from that source. What's new or unique about your study? How does it fit into the broader context of the issue or the public policy? What additional research questions may come out of it? Science always spawns more science, it seems. So I find that's often useful to know as well. And then, funding sources is often an issue, I think, in the public policy sphere. People have really, I think, in recent years started focusing on that. So that's a question I'm going to ask if it's not included in the study. I know different reporters have different approaches. I always like to have a look at the actual study and read through it and get questions. So oftentimes, if you've published in a journal that isn't open access, that's going to be the first thing I'm going to ask is, can I get a copy of it? And then you'll probably get a number of questions that probably betray my ignorance on how these things work. But I like to clear those up. I was trying to think too about, what would be helpful for scientists talking with reporters. And I think, one thing to be aware of is that many reporters are not scientists. They don't necessarily have a science background or much of one. And there are often technical terms, and there are some that are very obvious, and that's a technical term. And it's sort of the known unknowns and the unknown unknowns. There are, I have discovered through trial and error, some terms that are used in a specific fashion within a specific field, and they are used kind of uniquely, and it may be different from the general English usage of that particular word. So, for example, many years ago on this job, I wrote a story about something, probably maybe methylmercury, I forget now, and I described the chemical as a toxin. And I learned pretty quickly that is not the appropriate word to use in that situation, since toxin usually applies to something like a venom, something that is really and truly only naturally occurring. And mostly what I'm writing about are toxicants. So this is one of these lessons that I now hammer into everyone that comes to work with me, because it's just that thing that makes you look like you don't know what you're writing about. But it can really trip you up in a way that you don't expect, even when you're doing your best to communicate. So I think it's something to be it's helpful if you try and think about that when you're talking with reporters. Are there terms you're going to use that they might inadvertently misunderstand? So I think that was about it. I've got a few extra minutes if anybody wants to pose a question or two, or if not, we'll take it with the panel.
Any questions? Okay, we'll go on and then we'll take more questions at the end if it's okay with you, Maria. Yeah. We have a hard stop at 5 o'clock because there's another symposium here. So there you go. We want to keep it to time. Thank you so much. That was a terrific. overview of the gift that never stops giving, methylmercury. I was on the panel in '01, and I can still remember seeing those things coming up afterward. So thanks, Maria. And our second speaker is Kristen Lewis. Dr. Lewis is a project director within the Center for Public Engagement with Science and Technology over at AAAS, where she leads several projects, including facilitating communicating science workshops. And her talks is going to be on the whole issue of from hypothesis to headline and how the science news is made. So this is an academic perspective, right? Thanks for coming and being with us and sharing your knowledge.
Thank you so much for having me. This is a topic that is near and dear to my heart. I work at AAAS, as Dr. Dwyer mentioned, where I run the AAAS Mass Media Science and Engineering Fellowship. So if you're not familiar with this fellowship, it is a program that takes scientists, typically grad students, occasionally undergrads, occasionally postdocs, who are interested in science journalism and gives them an opportunity to be science journalists for a summer. So the people I primarily work with in this program do have science backgrounds and are new to the journalism side. I also work on these communicating science seminars, which take scientists and talk to them about how to talk to the media, how to communicate their science, how to avoid those jargon terms that do not necessarily mean the same thing to you that they mean to the reporter or to the public. Through the Mass Media Fellowship, I have a number of supporters, largely philanthropic organizations, other scientific societies. We also accept corporate support from Johnson & Johnson, so those are my research support, so to speak. Most of the money ends up going through to my fellows. So I work for AAAS, the American Association for the Advancement of Science. And we have a very simple mission: to advance science and serve society. Much like the IAFNS, Advancing Science for Impact, we really want to make sure that we are working on the science and putting that into practice some way. So how do we take science and get it to society? How do we take science and have it make an impact? The media is one way that we do this. So we're going to take a step back and really take a look at how we get from that science to the newspaper headline. So there are many routes that scientists can take to get their science out to the public. I'm going to focus first on this path down the middle. This is a very typical path for science to make it to a reader, to a listener, to an audience. First, you can start by going through a public information officer. These are often associated with your university, with your organization, with the journals who take published research, write press releases, say, look at this cool thing that we did at my university, or look at this cool thing our scientists did at this organization. Journalists often search for these press releases, and when they find something that piques their interest, they can then take that press release and move to write a story and do further reporting about that. Finally, you can then reach the readers, the listeners, the audience that you actually want to. Now, there are a number of pathways around this as well. Scientists can go directly to journalists, say, hey, journalist friend, I have this really cool idea. Or, hey, journalist I've worked with before, I've got new research coming out you might be interested in reporting on. Likewise, journalists can reach out directly to scientists. If they, particularly for people in my program, they are familiar with science, they know what is going on, they may be aware of cool new results that are coming out ahead of time. So there can be direct science journalist communications as well. Public information officers and press releases can also directly go to alumni, to the general public through other routes as well. Lastly, scientists can also engage directly with the public, and we can talk a little bit more about that, particularly with social media at the end, because I know that is something that you're all interested in as well. But for now, let's focus on this path down the middle. So I picked some random article in the New York Times that I found recently on health, food, and nutrition, and traced it all the way back to its journal article source. So here we have a paper, The Association of Sugar-Sweetened, Artificially Sweetened, and Unsweetened Coffee Consumption with All-Cause and Cause-Specific Mortality. This paper article tells you roughly what they studied, but it doesn't tell you any findings about what is in this journal article. This particular article was published in the Annals of Internal Medicine. The paper is dozen pages or so, 3,000 some words, plus many pages of tables and figures and charts and graphics. Mostly the people who are going to read this are other scientists and people who subscribe to this journal. It is a technical description of the research. It is filled with glorious science technical details that most people don't care about. I'm sorry, it's true. So this article was published, I forget when, relatively recently, I think in May, and the journal itself turned it into a press release. This press release came out at the end of May, and you see the shift in language already. So the title of the press release is Sweetened and Unsweetened Coffee Consumption Associated with Lower Death Risk. So you see them starting to narrow in already in the press release about including the findings, the major findings of the study in the title of the press release. Now this I pulled from a resource called EurekAlert. EurekAlert is a system that AAAS runs that gathers press releases from universities, from journals. It usually works on an embargo system. How many people are familiar with embargoes? Okay, that's great. Most of you are aware. If you did not raise your hand, embargoes are a way to get information to the press ahead of time. Typically, when you're announcing big results, you want a journalist to have access to that result ahead of time so they can do the reporting and hit publish on their story as soon as you release the results. And so this embargo system works really well as a way for scientists and journalists to work together to make a big splash when something comes out. And EurekAlert helps facilitate that embargo system. Now, the readers of press releases and the readers of things on EurekAlert are primarily other journalists. So here, the focus on this press release is general interest. It's about people who are interested in health, people who are interested in coffee. I know I've already had a cup of coffee here this afternoon, and I've only been here for an hour. And the audience is primarily journalists covering health. The other big thing to notice is that the word count from 3,000 some with the paper went all the way down to 407 words for this press release. So you do not have a lot of time to get into those massive technical details. You're really just trying to pull the core basic facts of the research into a press release. And now at this stage, you have a press release. So journalists will start to notice it. Once you have a journalist who's interested in a press release, they will start to reach out to people for interviews. There are a lot of different types of interviews that you might be contacted for an interview. First, it could be a profile piece. It could be about your work as a scientist on the whole. It could be about the work that you published specifically. So guaranteed that any author or any journalist who wrote about the study contacted someone on that author list for comment. You could also be contacted to comment on somebody else's work. In science journalism, one of the things that we teach our fellows, and that is very common practice, is to seek outside comment on a piece of research. So this could be somebody who might be cited in the research. It could be somebody else in the field who's familiar with it. You would often be given access to the article ahead of time, especially if it's not open access, as Maria mentioned. And you might be asked to say, hey, this is going to be embargoed. Please do not share this outside of this context until the embargo is lifted. But you might be asked to comment on somebody else's work. You might also just be asked to provide context. So in this particular study, they might say, okay, what other research has been done on coffee and mortality? If you are familiar with studying coffee, you might get asked to provide the general context. There are also the possibility that you could get contacted for an interview for something else, but we'll leave that relatively vague, because we're going to focus on the first three. So when you are contacted for an interview, there are a number of different questions that you should have as a scientist. First, what is the story about? What are you looking to write? Are you writing a story just on this research article, particularly on coffee and consumption? Are you looking to write a story about coffee more broadly? Try to get a sense of where the story is going. Journalists are also on deadline, so find out what their deadline is. It's very frustrating for people to say, oh yeah, I can respond and do an interview, and then find out that they're not available till next week when your deadline is tomorrow. So journalists often move very quickly. So as much as you can, ask what their deadline is and say, okay, I could get to you within that deadline, or I'd be available, but I won't unfortunately be able to make your deadline. So be clear and upfront with that. Ask who the audience of the article is for. Who will be reading this piece? If you're contacted by a journalist from the New York Times, you might have a sense of who reads the New York Times. But if you're contacted by a journalist at a more niche or a trade publication, you might not be familiar. You might not know who is reading that article. If you are right, if the readers of that article are other scientists, you might choose to use different language than you might if the journalist is writing a piece for the general public, which I maintain doesn't exist, but that's a different story. Ask the journalist what level of detail they need. Where will the story appear? When do you expect it to run? And an important thing is, who else are you talking to? You all are experts in your fields. You also want to know who else they're talking to, because you might be able to provide additional context saying, oh, that person has a very different opinion on this particular topic, so let me make sure to provide the balance, or whatever the case may be. Find out who else they're talking to. During an interview, you have several different roles. First, as a scientist, your role is to be honest. You obviously can speak to the science, and so you should be very clear about what the science says and what the science does not say. Journalists often like to get you to fill silences and tell more than perhaps you're comfortable saying. I know journalists often want so why does this matter? They want the broader context. They want the implications of this research. So what will this mean 10 years down the future? And sometimes as scientists, we're very uncomfortable saying what comes 10 years down the road as a result of this research, because we don't necessarily know. So it is important to say what you do know, what you don't know, and identify opinion versus evidence. You are more than welcome to say, I think this will lead to that, but be very clear about why you are saying that, whether that is opinion, whether there are facts behind that. You also want to be straightforward and confident. These are relatively straightforward terms, but we ask that you take confidence. You know what you're talking about. You are the expert in the field. The journalist may often repeat or reframe or turn into an analogy the type of materials that you're saying back to them. Let them know if that analogy is valid. Let them know if that works, or come up with a different way to refine their analogies if that is the case. Stay on message. When you're going to go in for an interview, it is important that you think about what you want your message to be. Why do you want to communicate with this journalist? What is your goal in communicating with this journalist? What is your message? What one key idea do you want this journalist to walk away with? That if you're commenting on some other piece of research, say this is the best research I've ever seen, or this research has a lot of fundamental problems. Figure out what your one key message is and really stay on track with that. Lastly, reiterate your key ideas. Again, this goes with your stay on message topic. In addition to the wonderful list of questions that Maria posted for interviews, one of the things that I often find journalists ask is, what else do you think I should know? Who else should I talk to? Is there something that you think I should have asked about but didn't? These are kind of like the giant flashing red light at the end of an interview, signaling that they are wrapping things up. And this is really your time to drive home your key messages. Say, this is what I want you to know, and reiterate those key messages. So as they wrap up an interview, really make sure you take that time to identify what you want that journalist to walk away with. So once you've gotten to an interview, finally we end up with a story on the New York Times. And so going back to this particular coffee drinking study, we find the headline, "Coffee drinking linked to lower mortality risk, new study finds." Now you notice even here, they dropped the entire sugar sweetened or unsweetened coffee bit. We just got coffee drinking. So we are continually getting a little bit more general as we go from the journal article to the final published paper. But this is also going to be read by a much wider audience. So national readers, the word count here is again 741, so surprisingly a little longer than the press release. That doesn't usually happen, but still much, much shorter than the published paper. So taking a look at how these two different types of research communicate. In a scientific journal article, we have the triangle on the left. We start with background. You get these long introductions saying everything that has come before you in the world of science. You get into supporting details, you get into methodology, and finally, as you reach the end of the paper, you get these results and conclusions. And so you have a triangle that starts with where you've been and gradually narrows down to what this particular study found. In the newspaper article, however, you flip that triangle on its head and you say, this is what the study found. And once you have the audience's attention, then you can move into the why that matters. And finally, you can build in some of those supporting details, some of that methodology, some of that broader context, some of that what was found before. But really, when you're looking at the scientific journal articles and the newspapers, they have entirely backwards methods of communication. So it is really important to keep these triangles in mind as you start to talk to the media and work with journalists, because they really want to know that bottom line piece right away. What is my headline? What matters? Why do people care? And those are going to be the key issues for a journalist. So let's go back and take a look at the journal article and the headline now that we've sort of had this broad discussion. Again, on the left, we have association of sugar sweetened, artificially sweetened, and unsweetened coffee consumption with all cause and cause-specific mortality. New York Times headline, coffee drinking linked to lower mortality risk, new study finds. So we lost a lot of the detail, but we also put the key finding of the result in the headline. And so it's just important to keep these in mind as you work with the journalists about how they will translate a study into an article. So we've fallen down this path from scientist to public information officer to journalist to the ultimate audience with this particular journal example. And let's focus a little bit on that last piece, the readers, the viewers, and the listeners. This is your audience. This is who you actually want to reach. You may have taken a convoluted step to get there, from the PIO to the journalist to the readers, but the readers are your goal. That is why you want to communicate with the media. That is who you want to reach. So as you're thinking about interacting with the media, really keep your readers in mind. What do they want? What do they find interesting? Why do they care? Why do they care about your particular research? How will your particular research affect their lives? What do they want to know? What do they find cool? Is it going to affect their children's future? Is it going to affect their future? Is it going to make their lives better? Really start thinking about why your research affects the audience. Now, if we start thinking about the American audience in particular, 91% of the American audience has some or a great deal of confidence in the scientific community. So despite what we sometimes think as scientists, the Americans trust scientists. This is the second highest group consistently in Pew Research of trusted people, second only to the military. Perhaps unsurprisingly, Congress is at the bottom of this list. But scientists have and maintain a good deal of trust within the community. Now, as I was bringing this up in some of our pre-talk discussions, I definitely got the question, but what about nutrition scientists specifically? And so I did a little bit more digging, and I found that only 11% of Americans have a mostly negative view of nutrition research scientists. This is from 2019 in Pew again, and 51%, a solid majority of people have a mostly positive view of nutrition research scientists. What I find really interesting here is that 38% of people have no clue. I don't know, they're fine, I guess. And so this really seems like an opportunity for everyone here to define yourselves. Only about 10% of the audience surveyed in this particular Pew poll knew a lot about the work of nutrition research scientists. And yet, those 10% of people who knew a lot were much more likely to have a mostly positive view of nutrition research scientists. So this is a huge opportunity for people in the field of nutrition research to define themselves, to spread the word about what it is y'all do, so that you can build this trust and improve that opportunity. And so one way that we might want to think about doing this is skipping this whole media route and going directly to the reader's audience that you want. And this can be done through social media. I know social media gets a lot of blame and a lot of excitement. It is a mess sometimes, but there are a real opportunity for scientists to define yourselves to the public. And so when you go to social media, again, you want to think about what is your goal in engaging on social media? How do you want to be seen? Do you want to be seen as an expert on a particular topic? Do you want to be seen as a mother, as a religious person? How do you want to be viewed on social media? How do you not want to be viewed on social media? And why would people follow you? So as you think about these different aspects of your identity and what you might want to highlight on social media, one thing that we like to suggest is creating a pro-personal account. This is a mix of a professional account and a personal account. So you might share photos of your dog on Twitter or on Instagram saying, look at how great this is. That brings in some of that humanity. But you might also want to be seen as the expert on coffee and death. So you might also post, so you might also post a lot about coffee research and mortality research. And you can create this blend of a professional and a personal account. And by doing these types of pro-personal accounts, you can hopefully build that 10% of folks who know a lot about nutrition research scientists and the work that y'all do, and continue to improve that trust in the work that you do as well. So just a few key takeaways. I could talk for hours about any one of these particular things, but a few key takeaways. There are many ways to get to your particular audience. Through the media, directly through social media, there are many routes to reach your audience. When you're talking with your audience and when you're talking with journalists, the bottom line comes first. What is that one key finding that you want your audience to be sure to take away? And then lastly, my challenge to all of you is to make yourselves more well-known, because nutrition scientists are a big question mark, it seems, to the majority of the American public. And so what can you do to make yourselves more well-known and to help bridge that gap with the audience? And with that, I will stop and be happy to take a question or two.